Hello everyone, we are now at module 11, the last module for this course. So we will start with lesson 11.1, all about sequences and series. So this will serve as an introduction to the entire module. Okay, so let's start with the definition of a sequence. Now an infinite sequence denoted by an inside curly brackets, this one, is a function, okay? Take note of this. This is a function whose domain is a set of positive integers. So what are the set of positive integers? Also call them as the natural numbers, right? Natural numbers 1, 2, 3, 4, so on. And then the function values or terms of the sequence are represented by a1, a2, a3, a4 until an, so on, okay? And then sequences whose domain consists only of the first and positive integers, meaning that the domain is only a subset of the set of natural numbers, are called finite sequences. Okay, so let's come up with an example so that we can understand it a bit more. So let's say we have the function f of x is equal to 2x. Okay, and the domain is the natural numbers, natural numbers, or the set of positive integers. Okay, so let's write out our domain here. Just for clarity, let's say we have our 1, 2, 3, 4, 5, and so on. In our range, what do we have? So we have f of 1 is equal to 2, right? Equal to 2 because we have 2x. And then f of 2 is equal to 4. F of 3 is equal to 6. F of 4 is equal to 8. And f of 5 is equal to 10, and so on. Okay. So it says here in the definition that the terms of the sequence are represented by a1, a2, a3. So which are the terms of the sequence here? The terms of the sequence here are this one, okay? Okay, and this is our a1, this is our a2, this is our a3, a4, and a5, and so on until an. And it continues depending on our domain, okay? So if we write it in this notation, we can denote this entire sequence as um, so an, which is equal to 2n. Okay. Okay, so that's it for the definition of a sequence. Now let's try to do some more examples. Okay. Start with the first one. Let's say we have here. So example 1. Okay, write the first 4 terms of the sequence whose general term is a. An is equal to 3n plus 4, and b. An is equal to negative 1 raised to n all over 3 raised to n minus 1. Okay, so let's start with a is our solution. So we have right here an is equal to 3n plus 4. And the first 4 terms, now what does this mean? What do we have to do? So our domain is the set of positive integers, right? So the first 4 terms of that set is 1, 2, 3, and 4, right? So we just have to substitute 1, 2, 3, and 4 to n right here. So we will get our 4 terms. Okay, so it's that easy. So our a1 will be 3 times 1 plus 4. This should be equal to 7, right? Our a2 is 3 times 2 plus 4. Okay, so this will be 10. a3, this is 3 times 3 plus 4. You'll get 9 plus 4. That will be 13, right? So what's next? a4 is equal to 3 times 4 plus 4. And this will be 12 plus 4. That is 16. Okay, so that's basically it. So these are the first four terms of our sequence. How about letter B? Let's try to do letter B. Okay, so our A1 here will be, so we have negative 1 raised to 1, 3 raised to 1 minus 1. So negative 1 raised to 1. What do we get? We get negative 1, right? Then all over 3 minus 1, that will be 2. So negative 1 half. So A2, what do we have? So negative 1 raised to 2. Okay, 3 raised to 2 minus 1. So negative 1 squared, that would be 1, right? And then we have 9 minus 1. That would be 8. So the next one, A3 is equal to negative 1 raised to 3. 3 raised to 3 minus 1 is equal to, so negative 1 cubed, that would be negative 1 still. Okay, 3 raised to 3, that would be 27, right? Okay, minus 1, that would be negative 1 over 26. And then finally we have a4. This will be negative 1 raised to 4 over 3 raised to 4 minus 1. So what will this be? 1 all over 3 raised to 4. It will be 81 minus 1. 1 over 80. Okay? So these are now our first four terms of this sequence. Okay, so that's how you do this type of problem. And in the next video, you will do the other way around from given certain terms, and then we will try to find the general term for that particular sequence. Okay, so thank you for watching, and I will see you in the next video.